Okay, in this chapter, we like to solve first-order differential equation in such a form: y prime equal to fxy, or dy dx equal to fxy, the same thing. Okay, this is called first-order differential equation. We are not able to solve all of them. However, we are going to learn how to solve some special case of this kind of differential equation. The first one is called a linear equation. Okay, what kind of differential equation we call the first order linear equations? They are in this form. Any differential equation can be written in such a form. We call the linear equations. Okay, for example, if you have something like y times y prime equal to 1, then this equation is not linear because they cannot be written in the above form. Okay. Or another one, say y prime equal to cosine x, then times y. Then this equation is a linear, okay, because you can write in above form with this one with a piece of x equal to negative cosine x and g of x equal to 0. Okay, so anything can be written in the form of equation 1, we call the linear equation. Okay. So the purpose of this video or this section is to learn how to solve a first-order linear differential equation. Now, let's look at an example. So, let's try to solve this equation. Y prime plus 1/2 y equal to 3 over 2. Okay, now, let's think about it. How do you solve this equation? You will say, hey, let's integrate on both sides. Okay, so you can do that. If you do that, you got this. 1/2 y dx equal to integrate 3 over 2 dx. The first term is fine. You got a y. Integration, it's an antiderivative, and derivative cancel, give you y. Now, how about the second one? Second one is 1/2 integral of y dx. The right-hand side is fine. Give you 3 over 2x. Okay. Now, the question is, how about this term? Y here is a function of x. Remember, the solution of a differential equation is a function. So if you give me y, I can tell you the integral of y. Okay. However, we don't know y because y here is our unknown. Okay. So we cannot simply by integrating both sides of the equation to solve this one. Okay. So what we do, our goal is like this. We try to write on the left-hand side, we hope, write this one as one term, something prime. Then we can integrate on both sides to solve it. Normally, we are not able to achieve that. However, if we change this equation a little bit by multiply the whole equation by something we call integrating factor, we call mu. Mu here is a function of x. Mu times 3 over 2. Okay. So if we multiply the equation by same thing. If mu is non-zero, then we call this equation 2 and the equation 3. They will have the same solution. We don't want to change your solution. Okay. So then equation 3 will have the same solution with the equation 2. But after multiply by mu, we hope we can write the left-hand side as something like this. Mu y prime equal to mu 3 over 2. If we know what is mu, then we can integrate on both sides. We solve it. Okay. So now the question is, let me say that again. What do we try to do? We multiply our original equation by a function mu, which is called integrating factor. Then we got a new equation. We hope we got to write mu such that the left-hand side of equation 3 can be written as mu times y, whole things prime. Okay. Then we can integrate on both sides. Okay. So now, such mu exist? Okay. Now I can tell you for this example, if you let your mu here equal to e to the x over 2, we will achieve such a purpose. Now let's try that. Okay. So we multiply equation 2 by e to the x over 2 y prime plus 1/2 y equal to 3 over 2 e to the x over 2. Okay. Now, then the question is this sense equal to e to the x over 2 times y? Is that true? Okay. We can verify that easily. Prime. So e to the x over 2 times y prime. Does that give you, see, this is two functions multiplied together. Remember, y here is a function of x. So two functions multiplied together, take derivative, we need to use the product rule. So we fix the first one. Take derivative of the second one, give you y prime. Then fix y. Take derivative of that, give you 1/2 e to the x over 2. So that's exactly what we want. Therefore, equation 3 really can be written like this. 3 over 2 e to the x over 2. Okay. Now we integrate on both sides. If we call this equation 4, we integrate both sides of equation 4, we got e to the x over 2 y, and integrate this one, you got 3 over 2 e to the x over 2, which give you 3 e to the x over 2. Okay. Now, in this differential equation class, we need to integrate, you need really good on integration. Okay. If you have a problem to integrate this one, you need to go back to review your Cal 2. Okay. Okay, therefore, so we're almost there. Okay. From this equation, we solve for y. What do you need to do? Multiply e to the x over 2, negative of that on both sides. So that would give you e to the negative, okay. You integrate this one and plus c, okay. When you integrate that, you have so many antiderivative. Okay. So you got a x. So we multiply e to the negative x over 2 on both sides. Give you 3 plus c e to the negative x over 2. Okay. So finally we find our solution. Okay. So we find a solution. Solution is a function. Okay. So this y here, you take a derivative, they will satisfy our equation 2. You can check that. Okay. So let me summarize what we're doing here. We try to solve equation 2, which is a linear equation. So we don't know how to solve that. So what we do is multiply equation 2 by a function mu, which we call an integrating factor. Okay. Multiply by mu. Equation 2 and 3, they are equivalent, which means they have same solutions. If mu is non-zero. Okay. So, why we want to multiply by mu? We want to multiply by mu, then our new equation, the left-hand side of equation 3, can be written as mu y as a whole thing prime. Then we're able to solve it. Okay. So now the question is, how do we find such mu? In this example, I'm telling you we can choose mu equal to this. Then by doing this, we solve it. Okay. Now, I know you have a question. You said, how do you know our mu here for this example equal to this? That's what we want to find out next. Okay. How do we find the mu? Okay. Now, remember what we try to solve is a linear equation. In general, write like this. Any first order linear equation can be written like this. Now let's see how do we solve that. Just recall the procedure, okay? So we hope we'll write the left-hand side as one thing as a whole, take a derivative, okay? Normally we're not able to do that. Therefore, we multiply our equation on both sides by an integration factor mu. So we get several functions here. We got a y, we got a p, we got a g, we got a mu. They're all function of x. Okay. So we want to multiply integrating factor mu there, such that the left-hand side can be written like this: mu y prime. Okay. Obviously, not all the function mu can achieve that. So we want to see what kind of equation mu should satisfy such that this equation is true. Okay. So we want to mu y prime, we want to mu times y whole thing prime equal to mu times y prime plus mu p y. Okay. On the other hand, mu is a function of y, mu is a function of x, so is y. Therefore, if we use the product rule, these things can be written as mu y prime plus mu prime y. Okay. Therefore, this is the equation mu need to satisfy to achieve this goal. Okay. So from here you can cancel here, cancel there, cancel y, cancel the y. So this above equation can be written as mu prime equal to mu times p. Okay. P has been given, it's a given function. Okay. If you give me a linear equation, you have to give me p and g. Okay. So to find such mu, we need to solve this differential equation. However, this differential equation is easier to solve because they can be written like this: d mu dx, that's prime means, mu times p. Okay. If we divided the mu on both sides, we got this. Then we multiply dx on both sides. We got this: d mu 1 over mu equal to p dx. Okay. Now, if we integrate this on both sides, you got this. The left-hand side is about mu. Okay, this give you 1 over mu. Well, no, this integrate that give you ln mu equal to integral of p dx. Okay. You said, how about right-hand side? That I'm telling you, if you give me p, I can tell you what is the integration of p. So solve here, my mu here is equal to e to the integral p dx. Okay. So that's how you find your integrating factor. Okay. If you find your integrating factor this way, how do we find it? Give me p here, plug in, integrate it, you find your mu. Okay. Once you know your mu, then if we call this equation 1 here, equation 2 here, then our equation 2 can be written as mu y prime equal to mu times g. Okay. Now we're able to solve it, right? We integrate on both sides, like you do this, dx. So left-hand side, antiderivative cancel with the derivative, simply give you mu times y equal to integral mu times g dx plus c. Okay. So therefore, your y here, you divided mu on both sides. 1 over mu times integral g times mu dx plus c. Okay. So if you give me p, you give me differential equation 1, that means you give me p. I can use this formula to find mu. Okay. Then you give me g and no mu, I can do all those integration, you find your solution. Okay. So this formulation is so important, this one. Equation 3. You can use this equation to find your solution. Okay. Now let's try that. Let's try that here. Okay. So remember our original equations like this. Y prime plus 1/2 y equal to 3/2. So our piece of x here is 1/2. Our g equal to 3/2. So your mu here is integral e to the p is 1/2 dx. That's why you got e to the x over 2. That's how we find such a mu. Okay. Then you try your y here is e to the negative x over 2 times integral. G there is a 3/2 e to the x over 2 dx plus c. You will get the solution we got before.